First of all, a little warning. I'm not a native English speaker, so I'm coming from the country maybe of the best beers in the world. But so I hope you will understand my English, and that I will understand your questions after all. Okay. That said, what is our agenda today? First of all, I will describe you the company I work for, the application we've developed, the problem we still have today, that is a complete re-engineering of our user interface from an old-fashioned Web 1.0 interface toward a brand new Web 2.0 interface. We had to select a specific framework. I will explain you the choices that we had. Finally, we've selected the Google Web Toolkit. I will explain you why. And I will also give you an insight of what we've added and how we worked with GWT. And finally, I will show you some slides about our. So the GWT version of ContactOffice is already available as a beta version at beta.contactoffice.com. So first, what is ContactOffice? In fact, it's a collaborating and messaging web application that exists already since 1999. So we are one of the few survivors of the dot-com bubble burst. And I will show you what the different functionalities we are offering. How big are we? We had about 1 million registrations, but that doesn't mean anything. What is more meaningful is that we have today about 350,000 active accounts. That means at least one activity per month. We have, that's more interesting, 250,000 paying accounts for application. Our application is fully internationalized and works in 6 different languages. And our company is profitable since 2003. So we are offering a complete set of functionalities. First, a group organizer with a calendar, a sophisticated address book, to-dos, the task list, notes, bookmarks, and all the tools could be synchronized with a palm, with a smartphone, and so on. And all those functionalities are offering a lot of bells and whistles. You have all the tools are available through an RSS feed. You have different export-import capabilities, or you can dream of. We have also a state-of-the-art messaging component, offering a webmail, complete webmail. But also our mail application is accessible with other protocols like IMAP, POP. We have client, POP3 clients, IMAP client, SMTP server and client, and so on. And what is interesting is that we are using a common addressing scheme for different messaging technologies, so you can in a single operation, send the same message as a mail, as a fax, as an SMS, and so on. We offer also a documents repository accessible to the web or with a WebDAV protocol, so you can access directly your documents with your Windows Explorer, for example. The documents are available as RSS feeds, podcasts, for example, and you can share the document on the web. We are also offering other tools like a forum, wiki, a bulletin board, phone calls, and so on. What is particular in ContactOffice is that from the ground up, the application was built to work as a groupware. And we have implemented a very sophisticated access control mechanism at the object level. Well, an object may be a contact, a calendar, event, a task. You can apply an access control to tell, for example, that event could be seen by that and that person, that and that group, and so on. So it's a very fine-grained access control that we've implemented. So ContactOffice is available either as an application service provider application, but we've also sold the application for large users to run the application on their own infrastructure. So we've various customers like mobile operators, large universities, airway companies, either in continental Europe or in the United States, in Canada, and so on. We are very successful for universities. Well, that said, what are the technologies we are using? In the backend, we are using a pure Java backend, and since the beginning, we've only worked with plain old Java objects. So we didn't use enterprise Java beans since the beginning. And what is particular for ContactOffice is that we are not using a classical relational database, but well, an object-oriented database. That's a fantastic tool that gives a quasi-transparent persistency and a very efficient access for this kind of application where we navigate in the data. We have very few queries in the application. So the application is architected around a core business logic with various satellites, the web applications, SMTP client servers, POP3 client server, and so on and so on. So the application was built since the beginning to be scalable, and we run applications with 10,000 simultaneous users per front end. So that is for the backend. We are quite happy with the technology, but concerning the front end, the web clients, we've implemented since 1999 a classical web application with HTML, with technologies like HTML, JavaScript, and style sheets. And most of our pages are dynamic. We are using JSP as technology, and we have more than 2,000 pages. That's quite difficult to maintain. And we have not only the core ContactOffice, but we are developing specific versions for different customers. The application is also available for Pocket Explorer users, for Symbian users. We have also a WAP version and a prototype of voice XML version. So our goal was, about 2 years ago, was to re-engineer the user interface. We have a classical frames-based user interface, and we would like to switch to desktop-like Web 2.0 kind of applications with drag and drop, smart widgets, and so on. So we felt our client technology was obsolete. So the first step we had was to select a framework to make that migration. And in fact, there are a lot of excellent solutions. The first idea we had, remember 2 years ago, was to build our own framework based on JavaScript. We were working with smart JavaScript developers, but very fast we've seen that it was not our core business. We were doing what others were doing better than us. Our core business is to develop applications and not yet another JavaScript user interface framework. Another difficult choice was between Ajax JavaScript technologies and Flash-based technologies. You can make a very interesting user interface based on Flash with technologies like OpenLaSLO or Adobe Flex. But, well, what was a problem for us was a mix of XML and a script syntax. We felt it was not the best solution for us. And certainly for Adobe Flex, there was a kind of server-side lock-in. Other choices, possible choices are Silverlight. Silverlight and JavaFX are brand new. Silverlight was not appropriate with our backend. We have a pure Java backend, and Silverlight is not a good solution there. JavaFX and applets could become a new interesting solution if the Java virtual machines technologies evolved toward a lighter model. And it seems that this becomes the case for the beginning of next year. So another possibility was to use an ultra lightweight client. That means a client that does almost nothing, that interprets server-side commands. Examples of implementation of ultra lightweight clients are Eco2, ZK, Thinwire. The technology is very smart and offers the advantage that you can use all the Java libraries you want. But we have questions about the scalability of the solution. The stress on the server is very important, the bandwidth and the CPU power needed by the server seems to be too high. And last but not least, there are excellent existing JavaScript frameworks like Dojo Prototype, the Yahoo user interface, MooTools, and so on. And yes, the problem is that those frameworks are pure JavaScript. And what is the problem? In fact, JavaScript is a very interesting language, in my opinion. It offers powerful constructs that are not available in other languages like Java. For example, functions could be used as first-class objects in JavaScript. You can manipulate functions like any other object. That's very powerful. JavaScript has already closures. Interesting concepts like prototype instead of classes. Meta-programming is very easy in JavaScript. You can build a program like a string, and you can interpret the string at runtime. So that's very powerful. All objects, in fact, are dictionaries, like hash tables. That's very flexible. There is a dynamic typing, so you can quickly write small programs. So is it a paradise? No, I don't think so. So remember, our problem is to migrate a complex, quite large Java user interface. And what we feel is that JavaScript is not appropriate for quite large applications. Well, large is some thousands of lines of code. And then JavaScript becomes very dangerous. It is a very dynamic language, in which you can declare a variable anywhere on the fly. With a very weak typing, you can assign anything, almost everything to anything. And with the eval mechanism, you can evaluate any string at any moment as a program. So that kind of feature makes that it is impossible to implement some very powerful IDE's operation. For example, refactoring that we are using every day in Java. I want to rename that function, or I would like to search that variable. That's absolutely impossible in JavaScript. You can, yes, what you can do is syntactical search or some syntactical refactoring, but those are very dangerous operations and are failing in many cases. Another problem is that in Java you can have real-time compilation, detect instantaneously syntax error. It's very difficult or impossible in JavaScript. Yes, and readability is more subjective question, but is also an issue in JavaScript. The scoping of variable is, and the encapsulation is quite weak, so it's difficult to build a good object-oriented software with JavaScript. And a very important issue is that most of the errors are detected at runtime, and not when we would like, it means at compile time. Another drawback of JavaScript is not the language itself, but the document object model and the differences between the various browsers makes things very difficult to handle. Well, that means that to handle an application like ours with tens of thousands of lines of code with multiple developers, that requires an extremely strict discipline in JavaScript. Rules, conventions, and even with those rules, the development is still difficult. So for us, the solution, and since day one, when we heard about GWT, was to use that framework. Well, I'm not affiliated with Google, so it's my opinion as a software engineer. So yes, you know GWT is a Google Web Toolkit. It's a framework used to build Ajax applications in the Java language, because GWT integrates a Java to JavaScript translator. The software, both the user interface components and the compiler are fully open source and available under a very liberal license, Apache 2. GWT doesn't require any plugin. It's a Java program, but it's translated in standard JavaScript, so no plugin, no Java virtual machine needed. And well, it's a technology that is just 1 year old, but we feel that it is very mature and you can use it for professional applications. But the features that appealed to us in GWT were first performances. If you look at all the mechanisms that were implemented, like a very aggressive caching mechanism, a code optimization, compression, make very efficient JavaScript applications. Another important point was a very clean backend integration. Yes, we were lucky. We are using pure Java backends that makes things easier, but you are not tied to Java backend. You can also have a PHP backend with and you can use JSON as a communication mechanism. Another interesting aspect was portability. The JavaScript compiler compiles, in fact, produces today 5 different objects code for 5 different families of browsers, Internet Explorer, Alt Mozilla browsers, and so on. And so without any conditional code. If we need to access native JavaScript functions, it's still possible with GWT by using a mechanism called JSNI for JavaScript native interface. So you can call JavaScript from Java and Java from JavaScript. And yes, another important feature was internationalization. So there is an interesting internationalization mechanism implemented in GWT, and that was a critical feature for us. A drawback of GWT is that a kind of Java knowledge is required even for user interface designers. And that's a difficult point, because generally UI designers are used to use style sheets, text-based languages, but not Java. That's, and using only style sheets, in our experience, it's not realistic. So the Java used by GWT for the front end is still Java 1.4. The 1.5 version is coming soon, promised for GWT 1.5. It offers a subset of standard libraries, java.lang, java.util, but with some restrictions caused by yes, for example, there are no introspection mechanism, no dynamic class loading, and that allows better code optimizations. But in Java util, you have almost all the collections you need implemented in the framework. So the compiler is an optimizing compiler with some interesting features like a dead code elimination, a function that is never called in your code will not be generated in JavaScript. Another interesting mechanism is the deferred binding. So you do not need to have conditionals like if Mozilla, if Internet Explorer, and so on. So there is another mechanism implemented in GWT that allows you to produce clean, separate object code for the different platforms. That reduces the code side also. So as of today, the UI components library is relatively rich. It's not as rich as other libraries, but from version to version, new components are added, new widgets, panels, but we felt there are some important missing pieces. So where GWT is really powerful for us is at the software engineering point of view. There are a lot of tools we can use to develop, in fact, a JavaScript program. As you are writing a Java program, you can use all the Java tools you can dream. There are very clean Eclipse integrations, JetBrains, NetBeans integrations. There are other tools. You can use a standard debugger. So you can debug at the Java level a complete application. Testing, there is the JUnit framework implemented in GWT. Refactoring, you can use your standard Java source control system. And what was impossible in JavaScript becomes possible with GWT, smart searches, navigation in smart navigation in your program, autocomplete, quick fixes, and so on. And another very interesting point is that a lot of errors are detected at compile time and not at runtime when your users are using your application. So, but we felt there are some missing pieces, and the first point we felt was critical for a large size application was to develop a clean model view controller, model view framework. That's for us a key factor for to become successful to build a good large-scale application. That's particularly necessary because the kind of applications, the A in Ajax is in fact something difficult to handle. The asynchronous aspect of the application makes things particularly complex. A positive side effect of using a model view controller framework is that you can separate, you can ease the collaboration between the UI designers that are working mostly on the view side and the software engineers working mostly on the model side. I will come in more details on that later on. We've implemented also a drag and drop engine, still missing in GWT as of today. That part of our software is put in the public domain, so it's open source. We've implemented an attractive look and feel. Contextual menus are still missing in GWT. We've implemented a marquee selection, a selection of rectangular zone to select the different objects. We've developed also splitters to make resizable windows, rich text edits, but now those features are available since yesterday in the brand new GWT 1.4 version. Also a data grid was developed. Some widgets like enhanced dialogues and property pages. Other widgets like editable labels, labels that become text boxes to change the text and so on, progress bars. And one lesson we learned when extending the GWT framework, that nothing was made impossible by GWT itself. So even low-level mechanism like the drag and drop was possible to develop even without a line of JavaScript code. It's pure Java. So to give you an idea of the current state of our migration, we've spent about 1.2 man-year, but it's fast growing now. We've already written about 35,000 lines of Java code, and we expect when the migration will be completed with the same features that as our current application, we will have about 50,000 lines of code. That gives, we produced 250 files and about 500 classes. And yes, the problem is that once compiled as JavaScript, that gives us 5 megabytes, about 5 megabytes of JavaScript. It's a huge program. But fortunately, once compressed by using a specific option of the compiler, we have only 900 kbytes of JavaScript. The kind of compression used by GWT is unfeasible with the classical JavaScript. Here, the compiler has the knowledge of all the identifiers you are using in the application, And so, for example, all the variables names are reduced to 1, 2, or 3 characters long and no more. And that's the kind of thing it's impossible to achieve in pure JavaScript. And another good news for us was that with the new 1.4 compiler, the code size was reduced by 25%. Once zipped, well, most of the web servers are able to compress the code. That gives for GWT 1.3 about 270 bytes, and we expect for GWT 1.4 about 200 bytes. That means 1 second of transfer time for a high-speed connection, so that's nothing. And better, the caching mechanism offered by GWT makes that you have only to download once the object code, the name of the file is coded in such a manner that you can use very aggressive cache. So how are we working? Yes, there are 3 kinds of actors. In fact, software engineers, UI designer, and the responsible for internationalization. First of all, the software engineer developed the data side of the front end with the remoting of the different functions, and also the model classes. And she is responsible also to build a very raw UI design with simple panels, simple widgets, and so on. And possibly she needs to develop custom widgets. Then the next step is the UI enhancement. So the relatively easy part for the UI designer is to develop specific style sheets. The difficult part for a normal UI designer is to enhance the Java UI design. So you have to tweak the panels, the widgets. You have to adapt the formatting. That requires, as of today, that requires a good Java knowledge. It seems that Google is working hard on that issue. So we are using heavily Subversion as a data repository, and in fact that is an excellent tool. You can work with a UI design in a sandbox, and the software engineer can control the trunk, for example. So, and there are various iterations, again, between some naive view enhancements and better UI enhancement by the UI designer. And finally, the person responsible for internationalization can adapt the code. That's at the Java. It's also a Java operation, but quite easy to handle. So I told you earlier that we are using a modified model view controller model. In fact, we are using not a controller, but a remoting component. I will explain you what the different component means. So the model is, in fact, the data representation in our client application. In the model, we've implemented abstract classes like an abstract model, model object, a model folder. In fact, those classes implement all the common features of all the model objects. For example, a contact in an address book is a model object. An address book is a model folder. A mail folder is a model folder. You can, so you can have a common feature at that level. The remoting classes implement what you know. If you are developing GWT applications, service async classes, and also data transfer objects. What is important is that those classes are shared between the front end and the back end. The same classes are compiled for both sides of the application. Well, a characteristic of an AJAX application is the asynchronous type of work. And in GWT, you can make asynchronous calls to the server, and the server will answer with classes implementing, with objects implementing the async callback interface. Well, that kind of, ideally, we would like to mask that asynchronous kind of work. We would like to mask those things to the view developer. Remember, we would like to make those things as simple as possible. Unfortunately, it's at this moment impossible in JavaScript. To mask correctly those features, you will have to work in a multi-threaded environment, impossible in JavaScript. So, in the first, if you are lucky, you can use synchronous calls between the view and the model. For example, I need to fill the different attributes in my dialog box. I can ask to the model, please give me the address of that person. But you need to be sure that the data were previously transferred from the server. What we classically use between the view and the model to solve this problem is an observer design pattern. So you request the model to warn you when the data, that kind of data is available. So you can add multiple listeners to a model object. We've added another way to communicate between the view and the model that proved to be interesting. In some cases, it's an asynchronous call, but with a comment piggybacking. So you ask the model, execute that comment when the data are available. So that slide and the next one are only intended for experienced GWT developers. If I don't know all the elements, but yes, it's a warning. So what we found interesting in our to implement was an enhanced async callback. So async callback is the mechanism used by asynchronous call to communicate the data transferred by the server. It's the good place to handle the trouble, the wait icon. You can count the incoming and outgoing calls, and so that's the good place to handle that feature. And it's also the good place to handle generic RPC exceptions, to handle those exceptions in a very generic way. And yes, another interesting point is, as I showed you previously, it's a good place to insert a comment piggybacking mechanism. So you can add to a standard callback a comment that will be executed when the call is successful. So an example of that comment piggybacking is this one. And that pattern is used everywhere in our application. So the user creates a new event in the calendar. We would like to create a new event in the backend. And when that event is created, we would like to immediately open a dialog box to edit its parameters. With this mechanism, things become relatively simple. So we have only to call, that's the view part of the application. We have only to call the save function of the model. And the save function has an additional argument, a chained comment. And that comment will be executed when the callback returns successfully. So you have only to call the save with the show dialog command. That's in fact a very simple command. When executed, that command will open the dialog box. But at that moment, when the dialog box will be opened, the data are available, and so all things are working correctly. That pattern could be used simultaneously with a classical observer pattern without a problem. This one is unicast. You can only have a single comment, and the observer is multicast. You can have multiple lists for a single event. So that's our current interface with frames, with checkboxes like most of current interfaces. That's an idea of the new one. Yes, you can test it by yourself at http://beta.contactoffice.com, provided you are not a current Safari user. ContactOffice is not compatible with old version of Safari. You can use nightly builds of WebKit if you like, but not. There is a bug in Safari and it will crash at this moment, but not WebKit. So some example of extensions we've built around GWT. That's a standard menu bar, a GWT menu bar. We've added icons and so on. Yes, the splitter is now a part of GWT 1.4. There is an example of a frame. That code comes directly interpreted from the server. Another important component we are relying on is the tree, the folder tree. We find a folder tree in almost all the tools in ContactOffice, the address book, the mail, and so on. That component is in fact based on a standard GWT tree. We've included the tree in a composite. We've added our drag and drop mechanism to add the capability to, as a drag source, you can drag a folder to another folder, and as a drop target, you can, for example, drag an object here to the tree. We've also added contextual menus, and we've a generic tree view class implementing with a close relationship with the model folder and model object in the model. So in fact, the tree is very generic, and the code for a specific tree, for example, for the mail is maybe 1 page long. Yeah? Another important class for us is the list view. It's in fact based on the grid GWT component. We've extended the grid to add object selections with multi-selection, You can select with the control click, shift click, you can select a range, you can use a marquee selection. And what is also important, and for a lot of different applications, is that we combine the list view with a logical data grid. So we can provide a logical scrolling with a caching, and we don't need to fetch a complete table on the server side. So again, drag and drop source, we handle the special keys. The columns are clickable, so we are using the sort features of Java collections, and there are also contextual menus. We've an enhanced dialog class. We've implemented so that the property page dialog box that extends a dialog box that extends the standard GWT dialog box. So we've implemented a framework, for example, to validate automatically to enable automatically the save button to handle various standard features in multiple property pages. So the dialog box are modal or modeless. You can decide to make a dialog box resizable. It's not the case with standard GWT dialog boxes. And yes, there are different specific listeners available also. Another feature was to add a contextual menu. In fact, the contextual menu itself is very simple to implement with a standard GWT. You have only to insert a menu bar in a pop-up panel. So there are two standard components of GWT. What is very hard is to invoke the context menu. It's easy in Firefox or Internet Explorer on a PC. It's a nightmare for other browsers. Impossible even in Opera. So yes, we've implemented a drag and drop engine with multi-selection, and yes, the same engine is used by a regular drag and drop marquee selection and splitters. An interesting feature for those of you that are migrating an application is that you can mix the old technology and the legacy technology. That's an example of that's the GWT program, but we can insert here a frame containing a JSP page, and we have in our application 10 different dialog boxes, for example, implemented this way. So you can insert JSP pages into a standard GWT dialog box. That's an example of our new calendar with, yes, the events. You can use drag and drop, the resize with the mouse, and so on. Towards about our backend, that's a conceptual view of what we needed to implement in our backend to implement the GWT services. In fact, the first component we had to create was a GWT servlet. It's an extension of the GWT remote service servlet abstract class. It's in fact a very simple dispatcher. It implements all the service classes, interfaces, sorry. And what the only thing that class does is to instantiate an instance on each RPC invocation of a specific handler, a mail handler, calendar handler, address book handler, and so on. What is interesting is that this class implements all the mechanisms needed to check the user credentials, to open, to commit database transactions, and so on. In fact, the actual communications with the business logic occurs in the different handlers. So in our experience, the GWT backend integration was very straightforward. Well, we are lucky because we are using Java, pure Java backend, but there the integration is very clean. We had an experience with another very interesting Java to JavaScript communication mechanism, namely DWR, and the migration from one library to the other was very easy. Today we have about 5,000 lines of code in specific to GWT in the backend. Well, one of the problems we have to face is now to synchronize correctly the front end and the back end versions. We have to generate the code at the same with the same versions. So we have a lot of to-dos. The number one point on our to-do list is usability. Well, it's not that easy to build user-friendly interface with those new technologies. We have a lot of bug fixes. We have still some missing tools, forum, tasks, group management to complete the migration. Another important question for us is customization. Well, we need to be able to generate specific versions for specific customers. All the customers do not have the same tools, have various look and feels. So we need to have a great flexibility to handle that requirement. And so one part of the solution is to use a dynamic CSS evaluation. For example, the CSS is as a JSP page with the conditionals in the JSP. But, well, for the debugging, we felt the JSP evaluation is not that easy in hosted mode. Another question is, do we have to handle customization at compile time or at runtime? So at compile time, that means that we will generate a specific object code for every customer. Or we can use conditionals in the source code. As the compiler is quite smart to detect desk code, that's a possibility. The compile time solution is cleaner, but at this time, if we have to generate multiple permutations of the JavaScript objects, that requires a lot of time, and we have a lot of different versions to generate every time. So another point we are working on is the portability to Safari and Opera, for example, the context menus. So the beta is available for non-old Safari users. You can access it even with the demo login. It's a completely free account. You can sign up for a free account to see what we've developed. Most of the application is in a good beta level. The calendar is still at an alpha quality level. So that's it. If you have questions about, yes.
How have you handled the legal accessibility requirements?
Not yet. No, we are working on the usability in general, and honestly, we have a lot of work to adapt the application. First for generic users, and yes, accessibility is not yet implemented in our application. And
is it going to be implemented at some point? Or
yes, that will be yes. In the next step, it will be yes. And I feel that it will be easier with a technology like GWT that with our older technology.
Yeah, hello. Could I just pick up on your point about usability again? When you said it's hard to make a usable application or an application with good usability, are you saying that with the GWT you're having trouble building the end-user application that's really usable? And if so, how do you think you're going to overcome that?
No, in fact, the problem we have is to, first of all, it's a question of choice. Do we have to implement all commands like a standard desktop application? That's not obvious. And there are a lot of discussions. Do we have to copy Outlook, for example, or other desktop applications? Or do we have to work in a completely different way, like strict, pure web applications? And in fact, you can see with our current user interface, we are still facing the choice. But it's not a question of feasibility. It's a question of philosophy of the user interface. Okay. So that's not, in fact, it's not a software engineer problem. It's, yes.
Mm-hmm. Okay, thank you. Just one other thing. You talk about how quick the code is to download and so on.
Yeah.
What's the performance load like when it's running? Is it efficient on the CPU and memory?
Yes, yes. It's very efficient. Yes. Difficult to tell you. It's subjective, but we feel the response time is excellent for the user. Now we have to program the application in a very careful manner to, for example, to use as less memory as possible. That's a difficult point. We have to be very careful about memory leaks, for example. Not memory leaks, standard JavaScript memory leaks, well-known Internet Explorer's problems, for example, because those problems are solved by GWT. But at the application level, there are a lot of possibilities to have memory leaks with listeners and so on. You have to unregister objects in a clean manner. But yes, we have. It's quite complex to handle the application cache. For example, with the list views, you have to cache just as a few objects as needed, no more. Else the interface will become unresponsive. Yeah. So.
Thank you very much.
Hi. Hi. Well, first, please excuse my broken English too. Second, I couldn't help noticing that after the JavaScript code that is generated by the application and by the GWT after compiling is still very large. Is still was it like 600 kilobytes large?
Yes.
Which, well, I guess that has to do with the fact that that ContactOffice is very JavaScript intensive, and you have lots of user interface enhancements there. But I wonder, is all that code in a single file, or is it split across several files so it can be loaded on demand? Or
it's a single file. So and in the current state of the GWT technology, it is mandatory. Mm-hmm. We need to, because there are no standard communication mechanism possible between two different sub-applications, for example. Okay. So we have to build the application in a single object. But well, 600K is not so large. If you take, for example, we've made tests with standard JavaScript libraries for our rich text editor. It's tiny MCE, But even that editor takes hundreds of kilobytes code only for a single component. So, well.
No, yeah, that was it. Thanks.
And from version to version, the code becomes more and more compact. The compiler optimizes more and more things. So we are optimistic for the future also. Mm-hmm.
You mentioned that some of your components you're putting into the open source community. How many of those components that you've custom written?
For the moment, we've only the drag and drop but in fact it's only a question of time, of energy to put other components in as open source. Yes, that requires from us a lot of work, in fact, to package those components, to maintain those components. But we are open to put those some of the components in the open source. Well, there are some parts of the frameworks that are really linked to our application, to our backend. It's not interesting for other people, but yes. The drag and the context menus, for example, could be interesting. And so.
Yeah, it'd be handy so we don't have to reinvent the wheel.
Yeah.
Yeah.
Uh-huh.